Today we are going to graph linear inequalities that are written in standard form. If you remember, as a little refresher, we used what was called the intercept method to graph these in the past. So we would make our eyes, remember it was also called the raccoon eyes method. This 0 is a y, so we plug it in here, which makes the 3y cancel out. I end up with 2x equals 6, divide both sides by 2, so x would be 6 divided by 2, or 3. This 0 is in the x position, so I plug it in for this x, making that disappear. And now I divide both sides by 3. 6 divided by 3 is a 2. And then remember, to graph it, I would simply graph 3, 0, and 0, 2. And then I would connect those two, and that was my line. Now we're going to graph this type of equation, but we're going to replace the equal sign with an inequality. We will use the same intercept method. So I make the eyes, plug this 0 in for y, that disappears, divide both sides by 2, I get 3. Plug this 0 in for x, that disappears, 6 divided by 3 is 2. I now graph these 2 points, 3, 0, 0, 2. But now I need to look at the inequality. Since there's an equal sign, I can make a solid line. Okay. Because there's a greater than sign, though, that means I'm going to shade one side or the other of this graph. These don't shade as easily as the equations that were in y equals mx plus b form. For this situation, we need to test a point to determine which side to shade. So we are going to pick a point on either side of the line, plug it into the inequality, and see if it works. If your point works, that's the side of the graph that you should shade. If your point doesn't work, you should shade the other side of the graph. You may pick any point you want, but if possible, I would choose an easy point like 0, 0. So I'm going to plug 0, 0 into this equation and see if it works. So x and y will both be 0. So 2 times 0 is 0. 3 times 0 is 0. 0 plus 0 is, of course, 0. So I just plugged a 0 in for x and a 0 in for y. Now you have to ask yourself, is 0 bigger than or equal to 6? Well, of course, the answer is no. 0 is less than or equal to 6. So this statement is false, which means this point is not a solution to our inequality. If one point is not a solution, that means all of the points on this side of the line are not going to be solutions. So since my statement was false, I'm going to shade in on the other side of the line. So I chose a point, I plugged it into the inequality, I multiplied, got it down to 0. Since 0 is not bigger than 6, this point is not a solution to our inequality. The solutions are on the other side of the graph. Let's try this one. Again, you start off making the i's, or the intercept method. 0 goes in for y, so that disappears. I get negative 3x and 12. I divide both sides by negative 3. 12 divided by negative 3 is negative 4. This 0 I plug in for x, so that disappears. 12 divided by 4 is 3. So I will now graph these 2 points. Negative 4 is 0, which is here, and 0, 3, which is here. Now, before you draw the line, check the inequality. There is not an equal sign here. It is just less than. So that means my line must be dashed. And now I pick a point anywhere on the graph to test. Again, I like 0, 0. It's the easiest one to test. So I'm going to plug 0, 0 into this inequality. So it'd be negative 3 times 0 plus 4 times 0 is less than 12. Well, negative 3 times 0 is just 0, and 4 times 0 is just 0. 0 and 0 is 0. So now ask yourself, is 0 less than or equal or less than 12? Of course it is. 0 is less than 12. That means that this point is part of the solution to this inequality. So since this point worked, gave me a true statement, that is the side of the line I should shade. So a false statement means that point's not part of the shading, and I should shade the other side. If I end up with a true statement, I should shade on the side of the point I chose. Let's try another example, number 3. Again, you always start by making the i's. This is a y, because it's the second number. Plug it in here. So I get 12 and 6x. So I divide both sides by 6. 12 divided by 6 is 2. This 0 is in the x position, so that goes here. That disappears. 12 divided by negative 3 is negative 4. Now I graph those 2 points. 2, 0, 0, negative 4. Before I draw the line, I check to see if there's an equal sign. There is, which means this will be a solid line. And then I choose a point, and I'm going to choose 0, 0, because that's an easy to plug in number. I'm going to plug that into the inequality. So it's 6 times 0 minus 3 times 0 is less than or equal to 12. Well, that's 0. That's 0. So 0 minus 0 is 0. Ask yourself, is this true? Is 0 less than or equal to 12? And it is. So that means that this point is an answer to this inequality, so I must shade on that side of the line. So for the last example, make the i's, plug this in for y, that cancels out. 10 divided by negative 5 is negative 2. Plug this 0 in for x. 10 divided by 2 is 5. Graph these 2 points. Negative 2, 0 goes here. 0, 5 goes here. Check the symbol. There's no equal sign, so it's a dashed line. Pick a point. I'm going to pick 0, 0 because it's easy. Plug it in. Now, you're probably getting used to this now. Plug a 0 here, I get 0. Plug a 0 here, I get 0. So this side is just 0. So I have to ask myself, is 0 bigger than 10? Of course not. So this is not a solution to this inequality. So I don't shade this side, I shade this side.